When solving or optimizing a problem, we're typically interested in one of two things: the zeros, or the places where the function crosses the x-axis, and the extrema, the maxima or minima of the function. Calculus is frequently used to identify extrema by finding the zeros of the derivative, but this assumes that you have a derivative available and that you have a reasonably fast way of searching it for zeros. So first we're going to deal with zeros in polynomials. Here we have a function that we've plotted from -1 to 2, and we can see that it does indeed cross the x-axis. At some point, looks like from our plot here that it crosses it at 1. So we're going to use that as our basis for investigation when we evaluate this. We're going to use roots, which returns the real and the complex roots of this. So as we saw from our function, there was one real crossing at 1.0, which is borne out here. And in this case, because it's a fifth order polynomial, we expect a total of 5 roots, the other 4 being imaginary. Poly works the other way. It takes the roots of a polynomial equation and turns them back into a polynomial array. So here I'm giving it roots 1, -1, and 0.5. I'm transposing this into a column vector, and it gives back to me the polynomial vector 1/2 minus x minus 1/2 x squared plus x cubed.